Okay. Um, 21 to 25. I think we hadn't even started this section, had we? I don't remember it. What do we have? 24? Wait, we're doing 20? Oh, got it. So then 24. Got it. We did, but I don't think we fully finished it. So then yesterday we were talking about sine of 2 and pi. The easiest way to explain it is sine of 2 is in between 1 and negative 1, whatever it is. A negative 1 and 1 for pi will still be a valid common ratio for a convergent geometric series. And then the last one, nth term test, divergent. Dun, 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 dun. Sound good? Okay, any other questions? 21 through 25. Okay, 26 through 30. 26. It's a partial fraction. Has to be a partial fraction. Ah, but it's a thumb trick. Let's review the thumb trick because it's so nice. Thumb trick says, okay, thumb trick. For me, it's a palm trick because my smartboard. Cover 1. What do I plug in? The 0 and negative 2 times 2. And negative 2 plus 1. Negative 4 over negative 1. Booyah. Ready? Cover. Literally cover, Gabby K. Cover. No, I think it's just easier, like if muscle memory. I don't know. I think it might help a little bit. Okay, so cover the x plus 2. Now look under x plus 2. What's the 0 of that? Now cover again. Plug in negative 2 everywhere you see an x. So on top, 2 times negative 2. On bottom, negative 2 plus 1. Negative 4 over negative 1. Ready? The x plus 2 gets a 4. Does that make sense? So then you guys walk me through what to do for the other one. What am I supposed to do? Positive 1, right? Negative 2 over positive 1? Booyah. And why is it so much easier? Because ln and ln. Now pause. Why not tackle it some other way? Because if you were to actually look at the bottom as a quadratic, why would this not be happy times even though you have an x up top? U prime is 2x plus. So wouldn't you have to go ahead and do this little like plus 3 minus 3 voodoo? And then you could go ahead and split up. And then you have to go ahead and do u and u prime. Then you have to deal with this guy and this guy. You could try to make an arctangent. But the problem is with arctangent, I believe, do you get it imaginary? No. X squared plus 3, that'd be 3 halves. 3 halves squared is 9/4. Ooh, 9/4 is bigger than 2. You would have, wouldn't even be arctangent. It'd be impossible. So this wouldn't be a bad idea. The only problem is it's not going to work. You won't get tangent, arctangent. You'll get u squared minus a squared. You're in trouble. Okay? So partial fractions were the best way to go. But what did they hint from the very beginning? They did hint. They didn't, well, all the ln's, but they also didn't write this as a quadratic. They wrote it in factors. That's kind of a hint. Does that make sense? Okay, anything else? 26 to 30? Yeah, Alan. 28. How do I get rid of, oh, there we go. Okay. Ooh, Caroline, I didn't look it up. Struggle. Taylor series. Is that one of our easy ones? Pause. What does it look like? 1 over 1 minus x. Okay, so you do minus a negative. That's true. Technically, is there an ln of 1 plus x? Do we have that one? It's from integrating the 1 over 1 minus x with a plus. Okay. Anyway, coming back. Some of you might want to add to that Endeavor card some of the typical variations like ln of 1 minus x, ln of 1 plus x, 1 over 1 plus x squared. Like you might want to look through and find questions and find variations and add them to the card. That might be a way of making it a little easier because then you'll recognize them better. It's an idea. But for those who are trying just to use the basics of the card, you take your 1 over 1 minus x, which is 1 plus x squared plus x cubed. But as everyone was just talking about, it's not a minus, it's a plus. So minus and negative, plug in a negative, which alternates the signs, right? But this is not squared. But what makes it squared? Yeah. So if you were to take a derivative, where'd they go? So if you were to take the 1 over 1 plus x and then derive, and then derive, you would bring down the negative 1. Well, okay, hold on. Let's get that first, and then we'll figure out how to change it to make it positive. How do we derive a power series? Of each term by term. That's why it's nice being a power series, term by term. So derivative of 1 is 0, right? Derivative of negative x is negative 1 plus 2x minus 3x squared plus 4x cubed, etc. Okay, now pause. What's different between him and him? Okay, so can I just multiply both sides by negative 1? So I need positive 1 minus 2x plus 3x squared minus 4x cubed. Now hold on, what are we supposed to be doing? The coefficient of three. That makes sense? Was negative 3 an answer? Hey, whew! They dropped the ball on that one. That would have been a great other answer to have. But they assumed you might make other mistakes. Is that okay? Pause. Is there always, pause. Some of you are forgetting. Is there always another way of going about these besides using the specials? Couldn't you always just use a definition, which is what they did? And take f prime, take f double prime, plug it in, plug it in. So worse, if you can't do the other and make it match, you can use this guy to make your Taylor series and go back to a Maclaurin. Why were we able to go back to a special Maclaurin? Because it was centered about 0. Okay, anything else 26 to 30? Okay. And it didn't even go to 30, right? Didn't it just go to 20? Oh, we did 28. Okay, calculator portion. How many of you guys, just, wait, just for my own knowledge, how many of you guys liked the non-calculator multiple choice better than the calculator multiple choice? It's okay. Like the non-calculator better? Really? How many of you guys like the calculator better? Okay. How many of you guys are like they were tied? I don't know, they're tied. And then 6 of you never volunteered. Okay, so, coming back. All right. What do we got? 76 to 80. Yeah. No, remember, it skips. You remember this, yeah? Okay. For the AP exam, it always goes from here to here, and then it skips a big portion so everyone starts over again on a new number. Does that make sense? Sorry, John, go ahead. Which one? 76. All right. You guys help out. Let's go and get some explanations from you. I've been talking too much. I'm going to go get water. Eileen, go ahead. What do you see? So because the function is not continuous, it couldn't be differentiable anyway. But what Eileen was saying was that since the two slopes, the two one-sided limits of what the derivatives would be, this positive value, this negative value, since they do not agree, the limit of the derivative could not exist. Does that make sense? Yeah. Okay. Ooh, I like it. I like it a lot. These are supposed to be easy. So hang in there. These are supposed to be easy, but you have to be able to see it. Hold on. Who wants to explain it? John. Yeah, please. 20 pi, yeah. Okay, so take it piece by piece if you don't mind.
So you want to start by relating radius and area first, because you're going to be looking for the area, which is area pi r squared. And it gives you the d of dt when you derive that, it would be dt equals 2 pi r dr dt.
What specifically in the word no dr dt? Rate of the radius increasing. Go to dt. And how can you translate rate of increase of area? dA dt. So if you didn't know at the beginning, like John did, like, hey, area, radius, let's figure out the relationship. If you didn't know that, here you say, wait, I need an equation with A and with R of a circle. So if you didn't know before, if you look here after you translate, well, I need something to, then take the derivative, implicit differentiation, like he said, plug and chug what you know. Now, oh.
You have to, because you go to plug in all your values, give you an r, so it gives 2 pi r equals
So circumference is 2 pi r, then you solve r is equal to 10. Now pause. Just in case this was an FRQ and the units weren't there, John, can you just explain why is it meters squared over seconds? That's okay. That's okay. Someone can. Why is it meters squared over second? Okay, that's one way of thinking about it. This would be meters, right? The radius, and this would be meters per second. That's one way. But what's another way? Area is going to be squared. Time is going to be, if worst comes to worst, if you translated correctly, you should know exactly what units you need. Now, what's the only time you're going to have to be careful? What if they gave you something like kilometers? Not that they necessarily would, but, and you needed meters, or vice versa. You needed kilometers, and you had, then you have to do some conversion, but otherwise we're okay. I didn't hear you. Okay, what else? Yeah. Ooh. Oh, never mind. Maybe. This might be the same as an AB question. I don't remember though. Brendan, you got it? Yeah, because you found that R is 10 and then plug in. Good. Okay. Katrina, you said you like this one? Take it away. Just think derivative of the outer, keep the inner, times derivative of the inner. Okay.
And then you plug in 1 for all the two different ones. When you do plug into the f prime, you don't look at f prime of 1, you look at g prime of 1. Oh, sorry, no, just g of 1.
Good.
So you look at just g of 1. And when you look in the graph, you'll see that g of 1 is negative 1. So then you go and you find f prime of negative 1.
Good. Just think compositions, you always need to start when solving on the inside. Not deriving, because you do derivative of the outer, keep the inner, but whenever you're plugging in, always start on the inside. Always start on the inside. Good. Any other questions? 76 through 80. 81 to 85? Yeah. Okay. 81 to 83, are there any others that? Okay. So 81, Guys, calculator question, yeah? All right. These limit ones, sorry, I'm trying to zoom in just a little bit. It's getting kind of small. Limit. Okay, careful. Limit. How do we think through limits? Technically two-sided, right? Okay. So to go from the left and from the right, right? Okay. So when we go to plug in, we only straight plug in with a limit when it works. When does it work when we straight plug in? When the function is continuous and non-piecewise, and the answer is not number over 0 or 0 over 0, which I guess would be discontinuous. Why would you not just plug in 1 and find f of 1 to be 3 and plug into sign? It's not the limit. It's the function value, but this is a discontinuous function. Couldn't we say that this function, f of x, some of you could do this, come on. Couldn't you say x not equal to 1 and x? And couldn't you actually say, hey, this is a line with 0, 0 and a slope of up to over 1? Couldn't you say that this is the same thing as 2x? Some of you do better at piecewise functions than graphs, which is kind of sad, but it's true. Because if you go to look at this, well, guys, if you needed to take the limit to 1, so where are we actually approaching? Another way of seeing it is you could say sine of the limit as x goes to 1 of f of x. What's the limit? 2. Plug into sine. Dun, 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 dun. Make sense? Composition of functions is a property of limits. As long as you're plugging into a continuous function or the composition is continuous, you can bring the limit in. Yeah. Or you can think of it as you were plugging in the 1. I know it's f of 1, but you have to come from either side. So be 1 below, 1 above. You'd be coming towards that too. Katrina.
This could be dangerous.
Go ahead.
You have just looked at the graph and said, well, it looks at 2. So
As long as you're thinking limit, yeah, that's okay. That's okay. Then just thinking the limit of will be, I mean, you basically did this in your head. Does that make sense? So that's okay. Number 82. Come on, related rates. But it's not even that crazy. Isn't it just rates? Not even really related. We don't have to come up with some formula on our own. Don't they give us a formula? So t cubed minus 4t squared plus 6 is a rate, is a derivative. Which of the following expressions gives the change in altitude? Change in altitude? Isn't that like a displacement? This is velocity. This is displacement. Don't we need to integrate? So we need to integrate between how they get their bounds when the derivative is 0. So couldn't we find the zeros using our calculator? They end up being 1.572 and 3.514. And then couldn't we, decreasing, look at the derivative that we graph and say, when is it below? We need the negative portion of the derivative, right? When the y values are below. You can say, okay, I just need the integral between those 2 times, because for those 2 times, since the derivative is negative, then the original will be decreasing. Dun, 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 dun. Is that okay? Okay. What do we still need to do next week? Have you guys play with what topics do you think the actual AP is going to have FRQs on? Forgot about that one, huh? You guys want to guess for Saturday? Pomegranates, okay. Like the drama yesterday. Whoa. Mangoes. You guys are going with fruit. There was fruit last year. Pencils. Another potato? They're going to bring it back? I don't think so. But maybe. Huh? Paper clips? Anybody else want to make any guesses for Saturday? Guns? Buying cars. Interesting. Okay. Ice? It's been a while since there was snow. Janet shoveling the snow was a while ago. Particle car plane. All right. We have a few ideas. We'll see what shows up Saturday. So, what? Individual shoes? All right, hold on. We have some few more about the silliness. Yeah. Just t cubed minus 4t squared plus 6. And your is between 0 and 8. What? Squared. You didn't put a squared, kid. You didn't put a squared next to the x. I just changed it. It's okay. We got it. Okay, 83. Kiddos. Really? It's okay. We got this. Someone tell me why A must be true. Gabby. Oh, no, you're okay. Why must A be true? Nicely done. Have to watch out the wording, right? So we're looking for who must be true. There's only one. Cool. So why is A false? You have no idea what it's doing in between. They give you no clues as to the increasing, decreasing. Now pause. Do I know there has to be an increase somewhere? An increase somewhere? An decrease somewhere? Does that mean there has to be a 0 of the derivative by MVT and IVT? Yes, but that doesn't mean it's strictly increasing, right? So couldn't it have decreased and then increased? Okay, so definitely don't know that or that. We don't know how high or how low it goes because we can't see all the values. How about letter C? Is the function having to stay positive by the exact same logic? No, it could have gone down negative. Who cares? Just had to come back up. So that's definitely a no. This one, must the derivative be negative for, I don't know. I mean, there's a decrease and a decrease, but couldn't it have done this thing, right? And then this thing, like it would have ended up, but yeah, we have no idea. They gave us no clue, like strictly decreasing, strictly increasing, not able to hit 0, whatever. So then the only one that we do know is between 0 to 4, f prime of c must equal 0. And they were so nice because they gave you f of a equals f of b. But even if it wasn't there, the average increase and the average decrease, there had to be one right here. Well, they gave you a couple f of a's equal f of b's. But do you guys see what I mean by the average? We saw those ones last year, a couple times this year, where they have us actually, they don't give us any f of a's equal f of b's, and we have to use that whole average argument, like, oh, there's going to be an average increase, therefore the derivative must be positive somewhere, an average decrease, therefore the derivative must be negative somewhere by MVT, IVT. Anyway, sorry, that's just one thing that they like to throw out. Any other questions, 84, 85? Katrina. Oh, sorry. As long as it's guaranteed, like the conditions are met. And like this one, it was easy because f of a equals f of b. So of course, yeah, just go for it. So you can look through and try to find, but I mean, these are technically the EBT, but the problem is I don't see all the values. So I know there must be a min and a max. I just don't know what's there or there. So just be careful as to, there are going to be several that look like a forever. But you're trying to basically usually steer away from the super specific ones. The one time super specific isn't bad is if they give you something like a derivative equals a number. And you're like, that's so specific. What could they be thinking? Must the derivative equal a number like 2 or 3 halves or 5 sevenths? They're thinking what theorem? Maybe intermediate value if they give you lots of derivative values. They usually don't, though. It usually would be an MVT, and you have to actually use the interval to get that random number. That's the one time where it seems specific, but it's according to a theorem. So if it says, must there be a place where f prime of x equals 7/3? You're like, 7? I don't even. But if you use the a and b and the f of a, f of b, it turns out to be 7/3. You know what I'm talking about? Yeah, you would find y2 minus y1 over x2 minus x1. It would end up being the random number they're talking about. That's the one time specific is usually not bad. They'd have to give you an interval. Yeah. Okay, anything else? 84, 85? Yeah, Alan. Okay. Ooh. Oh, maybe you guys could help me with this. I really think I need to make a card on over and under approximation. The struggle is, it shows up in Riemann sums, it shows up in tangent lines, and it shows up in Taylor series. Well, I mean, Euler's method, that's really just tangent lines, right? Euler's. So, let's just think about it. This one, trapezoidal sum over under approximates. Trapezoidal sum, just connect. I mean, you could do lots of baby ones, but why not just do one big one? It's going to follow the same pattern. Concave up, trapezoidal is going to over approximate, right? Concave down, trapezoidal is going to under approximate if you go with a straight line. Okay, so hold on. So trapezoidal sum over approximates. That's only going to happen if you have concave up. And then a right Riemann sum, hold on, hitting at the right and going back. So hitting at the right, going back. Ooh, hold on. Just do this. At the right, going back. One big one is super obvious. That's under for concave up. Right Riemann sum, that's over for concave down. So therefore, hold on, pause. Over for concave up. Wait, no. It was just under for concave up. Nope. Over for concave. What they're trying to say is, right Riemann sums are not based on concavity. Right Riemann sums are based on increasing, decreasing. Technically right and left. So you could just do it case by case and not even go to some memorized, contrived formulaic forever card that we could make. But as you guys look at, the only one that works for the trapezoidal going over and the right going under is going to be trapezoidal over connecting H1 to H2. Hey, what's the area of a trapezoid? Got it. So height 1 plus height 2, over approximate, right Riemann sum, under approximates. Okay. 86 to 90. John. 88. Gabby, be ready with yours, okay. 88. 1 over b minus a times the integral of a to b of f of, woohoo, that's average value, right? Pause. Which of the following could be the graph with the property that the average value is equal to 1? Couldn't we multiply the 1/2, multiply 2 on both sides? So the integral from 2 to 4 is equal to 2? Okay. So the area has to be 2 on the interval 2 to 4, right? Okay, so that's what we're basically looking for. I would go first to the ones that are totally geometric, right? So the ones that are totally geometric, I see this one right here, and I see a base of 2 and a height of 2. So what's a base of 2 and a height of 2? Okay, this one, I see, now I'm totally like this because I don't know, I like rectangles and triangles better. If you like trapezoids, go team. But I see a 2 and a 1, so that's a 2, and I see a 2 and a 2, 4 cut in half. Not seeing it. Over here. Ugh. What's the struggle? So why don't we keep going to the geometric ones? So I have a base of 1 and a height of 2, which is going to be 2 times 1 cut in half. A base of 2 and a height of 1, which is 2 cut in half. Oh, 1 plus 1 is 2. Dun, 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 dun. But, pause, let's think. Hold on. Doesn't this technically go here and then here? Question, is there more area that's going to be under or out? Under, for sure. Well, if this whole thing is 4, that's going to be greater than 2. Does that make sense? And then check it. Isn't this the exact same thing, but it's the outside instead? Check it. Half of this put with half of that is this. This is going to be greater than 2. This is going to be less than 2. You see it? This is these two put together. Less than 2 over 2. Dun, 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 dun. Huh? Oh, 1/2 base times height. 1 times 2 is 2, cut in half. 1/2 base times height. 1 times 2 is 2, cut in half. 1 plus 1. Oh, no. Because the area, the average had to equal 1, but what did I do to make life easy? I was like, well, he's the area, so multiply by 2. area equals 2. Does that make sense? More questions? Gabby. Okay. Guys, it's a graphing calculator problem, so getting this isn't hard, right? Okay. And I told us bounded in the x-axis, so we had to stick with the first quadrant. True? Now pause. Cross sections. What happens? Perpendicular to. We need that, right? Perpendicular to the x-axis. So I know right away it's going to be dx, right? Because my width is going to be dx. It's going to pop up in. Whoo! They gave it to you without a volume or an area formula. Sorry. Okay. Do you know your geometry? How do you find area of an equilateral triangle? Why? Equilateral. 60, 60, 60. This is a 60, 30 triangle. So if it's a 60, 30 triangle, couldn't I say that this guy is going to be root 3 over 2 times s? Sorry. Hold on. This one's equal to 2s. Careful. Sorry. 2x. One half s, 1s, and root 3 over 2s. There we go. That works. Why? Because area of a triangle is going to equal 1 half base times height. P.S. We've seen root 3 over 4s squared. I just never made you memorize it. Do some of you want to add it maybe to a card? Maybe the pre-cal stuff at the beginning? Sure, why not? Katrina. Because for an equilateral triangle, the altitude is going to bisect. So it's 1 half. Like literally it's just s cut in half. I wasn't even using triangles.
So what happened for the area is not 1 half.
Hold on, 1 half base. Oh, no. Base is the whole thing. I used the 1 half s for my little baby right triangle, but yeah, the whole base is s, and then the whole height is. Good question. So then what do? Square root of 3 over 4, base squared, or s squared. S is going to be top minus bottom. Top minus bottom is this guy minus 0. Dun, 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 dun. Dun, dun. No. That's physics. But they sometimes do have a geometric note. Sometimes. Yeah. The first page I think just says like, hey, you can use your graphing calculator and the trig values, like arc trig is the same as inverse trig. What else do they put? We're so close. Kiddos, right at the beginning of tomorrow, we'll just finish this up real fast. Then let's work on FRQs from, do you guys want 2 years ago so you haven't taken it yet? Okay. Maybe we'll do 2 years ago then, 2016. We'll do 2016. I mean, you guys hadn't seen the BC ones, but you have seen the AB ones on the BC. All right, cool kids. See you later. If you want broad shaped bread on the way out. Bye.